Hi, my name is Ajay Mishra and this is my 10 minutes video on static friction. So let's get started. So what is static friction? So it is the force of friction that exists between any two objects when they are not moving relative to each other. So remember, the friction force is related with the relative motion, not simply a motion. So let us consider an object of mass m is sitting on a plane, and this is my x and y direction. So we immediately draw all kind of possible forces, which is also called a free body diagram. So we have two forces acting on this object. One is a gravitational force, which is mass times gravity, and is always perpendicular to the surface of Earth. And second is the reaction force, which is also called normal force. Now in this moment, because this object has zero acceleration in the y direction, so normal force should be equal to the force of gravity. Now let's say we have applied a very small force and this object is not moving. So according to Newton's second law, if we apply a force, there should be some acceleration. So we know we have applied force, but there is no acceleration. We don't see any acceleration. So this implies that there should be some hidden force that's opposing the applied force, and that hidden force is called force of friction. So let's see how these forces are related with each other. So we use Newton's second law all the time, and we use in one direction. So let's say we use a Newton's second law in x direction. So according to Newton's second law, the net force, which is mass times acceleration, is always equal to the sum of two forces. So the first force is the applied force in positive x direction, and the force of friction is acting on the negative x direction, so it's negative. And we know this object is at rest, so the acceleration is zero, and the total force is equal to the force of friction. Now what happens if I increase the applied force? So if I increase the force gradually, the force of friction will also increase simultaneously. And there will be a moment when the applied force will win the force of friction, and this object will just begin to slide. So remember, when these objects just begin to slide, the friction force is called maximum static friction force, and is represented by F max, and sometimes it's also called limiting friction. So what is the cause of this static friction? That's very important. So when we see in an atomic scale, so in a microscopic scale, the point of contact between the two molecules are very, very close, and they experience some kind of intermolecular forces, and that force is called adhesive force. So remember, this adhesive force or intermolecular force is responsible for the friction. So if we want to move this object, we have to overcome this adhesive force, which is the maximum static friction force. Let's see some other properties of static friction. So the first property is the force of static friction is always acting opposite in the direction of relative motion. Okay. Second, this friction force is always acting tangential to the point of contact. Third is the force of static friction depends upon the material and the nature of the material. So if I change this material or this object, then the properties of friction will be different. And finally, but most importantly, the maximum force of static friction, which was F max, is always proportional to the normal force. And we'll discuss this fourth point, which is very important, in more detail. So, we know that based on the laws of friction, that the maximum force of static friction is always directly proportional to the normal force. So that is, the max force is proportional to the normal. Now we want to remove this proportionality sign, and we can do this by using some constant term, and this constant is mu s, where s represents the static friction, and this mu s is also called coefficient of static friction. Now if it's a moving object, then we'll say this thing as a kinetic, so coefficient of kinetic friction or dynamic friction. So anyway, so we are not related with the kinetic at this moment. So let's talk about the static. So mu s again represent the coefficient of static friction and is given by the total static maximum friction force divided by the normal, and it's a unit place. It has no dimension, and the reason is because in the numerator the force is measured in Newton and the normal is also a force and is measured Newton, so they cancel and they have no units. So coefficient of static friction is a unit place. And second very important thing you need to remember is the coefficient of static friction is totally independent of surface area and the mass of an object. So that means it doesn't matter if your let's say if your surface area, contact area is very small, or if your contact area is very big, the coefficient of static friction always remains same. And it's also independent of the mass. So if this mass is 10 kilogram or 50 kilogram, mu is always same. It always remains constant. But it only changes when you change the materials. Okay, so let's take some other example when an object is sliding down an inclined plane. And this is very important. So let's consider an object of mass m is sliding on an inclined plane, which is inclined by an angle theta. And this is my x and y direction, so you are free to choose any axis direction. Okay, the result is always same. So we draw all the possible forces. So again, weight is always perpendicular to the ground, to the surface of Earth, but the normal is perpendicular to the surface on which object is sliding. Okay. Now because this is sliding, so there is also a friction force, which is the maximum friction force, because in this situation we consider that the object just begin to slide. So what we need to do is, this weight or gravitational force has some inclination. So remember, when any force is inclined to a given plane, this force has always two components, that is x component and the y component, also sometimes called a horizontal component and vertical component. So you can resolve this force into two components. The x component is given by the force times cosine theta, and the y component is given by the force but sine theta. So remember, cosine is always associated with the angle. So we do the same thing. So we reproduce the normal backward, and using the geometry, we know that this angle is also a theta, which is angle of inclination. And we resolve this force based on this line, which is our y-axis, into two components. So the x component, it will be my force, which is mg cosine theta, and the y direction force is mg sine theta. So let's use the Newton's second law in x direction, in this direction. So again, according to Newton's second law, the net force, which is mass times acceleration, is always equivalent to the sum of two forces. Now remember, in this x direction, only two forces are acting, right? One is mg sine theta, and second is the maximum static friction force. So the net force should be equal to the sum of these two. So that's what I have written here. So mg sine theta, which is in positive x direction, but this force is acting in the negative x direction, so we got the negative this force. Remember, this maximum static friction force is equal to the product of coefficient of static friction and the normal force. So we know these things, right? So we replace this force with the coefficient of static friction times normal, and we calculate what is acceleration, because our target is to find what is the acceleration when this object is sliding, but based on the static friction. So this is the acceleration. Let's say this is our equation 1. We also apply Newton's second law in the y-axis. Okay. So in the y-axis, again, you have two forces. One is the normal, and second is the mg cosine theta. So again, the net force, which is Newton's second law, is ma, is the sum of two forces. So the normal is in positive y direction, mg cosine theta is in negative y direction. If we see our choice of axis, but this object is not moving in y direction. That means the acceleration is 0. So acceleration is 0 and normal is equivalent to mg cosine theta. Okay, so let's say this is my equation 2. And what I do is simply I use this equation to solve and calculate what is acceleration. So when we combine equation 1 and 2, so it's very simple. We put the value of normal in these equations. Okay, so it's mg sine theta minus coefficient of friction. Instead of normal, we have mg cosine theta, and the mass is as it is. We do a further simplification. So mg is common, so we take this out, and because we have a mass in numerator and on denominator, so we cancel these two, and finally we are left with the equation of acceleration when this object just begin to slide with a maximum static friction. And this is the final acceleration, which is measured in meter per second square. Thank you very much.